Good morning, champs. In the last video, we learned about the ideal gas law and how pressure, volume, and temperature are connected. Now comes a very important idea. In thermodynamics, we often control one of these variables and observe how the others respond. These situations have special names, and you will see them in almost every problem. Let's start with the first one, an isothermal process. Isothermal simply means that the temperature stays constant, so T is constant. If we go back to the ideal gas law, this means that P times V is constant, so pressure and volume are inversely related. If the volume decreases, the pressure increases, and if the volume increases, the pressure decreases. Physically, this means we are moving the piston slowly while allowing heat to flow in or out, so that the temperature does not change. In a pressure-volume diagram, this process appears as a curved line. Not a straight line, but a smooth curve. Now let's look at the second case, an isochoric process. Isochoric means that the volume stays constant, so V is constant. This happens when the piston is fixed in place and cannot move. If we now add heat to the gas, the temperature increases. The particles move faster, collide more strongly with the walls, and the pressure increases. So in this case, pressure and temperature change, but volume stays the same. In a pressure-volume diagram, this is a vertical line, because the volume does not change at all. Now the third case, an isobaric process. Isobaric means that the pressure stays constant, so P is constant. This happens when the piston can move freely and the external pressure remains the same. If we heat the gas, the temperature increases. The particles move faster and the gas expands. So the volume increases while the pressure stays constant. In the pressure-volume diagram, this is a horizontal line because the pressure does not change. Let's summarize. In an isothermal process, temperature is constant and pressure and volume follow a curved relationship. In an isochoric process, volume is constant and only pressure and temperature change. And in an isobaric process, pressure is constant and volume and temperature change. If you remember these three cases, you already understand a large part of thermodynamics. And more importantly, you can now recognize what is happening in a problem. In the exercise we will solve next, the entire process is just a combination of these three types. So the key is not complicated math. It is identifying which process is happening at each step. In the next video, we will take this knowledge and start solving a real thermodynamics problem step by step.